Hello dear students, this is RAKSHA Shetty and you're watching Edubassa, your homely learning channel. So in the last video we learned about the states of matter. Today in this video we'll be learning about the changes in the states of matter. So without further ado, let's get into the video. So these are the contents of today's video. We are going to learn about the introduction of the states of matter, the activity and the effect of change of temperature, melting point of solids, latent heat of fusion, boiling point of liquids, latent heat of vaporization, Kelvin scale of temperature, sublimation of camphor, which is again activity, effect of change of pressure, interconversion of states of matter, and finally conclusion. So first is the introduction part. So we already know that matter do exist in three states, which is solid, liquid and gas, which I'm sure you all know. If you didn't watch the previous video, please go and watch, and do not forget to subscribe to my channel. Yes, so we already know that there are three states of matter, which is solid, liquid and gas. If it is solid, for example ice; if it is liquid, water; if it is gas, water vapor. Okay, so this is how the solid can be converted into liquid and the liquid can be converted into water vapor. How does matter change its state? Okay, so in this video particularly we are learning about the change in the states of matter, and how does this matter is going to change its state from liquid to solid, and from solid to liquid, and from liquid to gas, and again that is also there, which we will learn further. Okay, from solid to liquid and liquid to gas, or whatsoever interconversion, how can it be done? So that is by the main two factors, that is by the temperature as well as the pressure. Because of the temperature increasing or decreasing the temperature, or increasing or decreasing the pressure, the matter can be changed. So we are going to learn how exactly it is going to change in this video. So first let us concentrate on the activity. First we are going to take in a beaker 150 gram of ice, and we are going to suspend a thermometer in the same beaker with the bulb touching the ice. With the bulb touching the ice, which is the thermometer, laboratory thermometer. We are going to use laboratory thermometer in which the bulb is going to touch the ice, and we are going to start heat the particular beaker of ice with the help of the burner, and also we are going to place the glass rod in order to stir it gently. So what are the observations in the activity? First we are going to note the temperature as soon as the ice starts melting, and we also going to note the temperature when all of the ice will become water, and then we have to put the glass rod in a beaker and heat till the boiling is going to start, and then again we have to place the thermometer and also observe the temperature when the water is going to change to that of the vapor. So when the ice is melting, what will be the temperature? The temperature will remain constant. The temperature will remain constant. It will be the same. Okay, why isn't changing? We will learn further. And as soon as the ice is going to become water and the temperature is going to increase, and at one point of time when the water is going to convert into the vapor, the temperature reaches to 100 degrees Celsius, and it is not going to change beyond that. Later on, after it is going to turn into the vapor, then it again the temperature is going to increase. Why exactly it is happening, all of that we are going to learn further in detail. So what is the record we are going to observe is nothing but the solid is going to convert into liquid by the process of melting, and the liquid is going to convert into the gas by the process of boiling, and the point at which the solid is going to convert into liquid, that point itself is called as melting point, and the point at which the liquid is going to convert into gas, that point itself is called as boiling point. Right? Yes. So this is the experiment that we are performing. So you can see over here, the beaker is taken, within that the ice is taken, and a glass rod is being kept, and as well as the thermometer is being kept. This is the burner. So we are going to heat the ice with the help of this burner. We are going to provide the temperature with the help of the burner. Now what happens, the ice is going to melt, and later on it is going to become water. Then the temperature is going to increase, and later on when the water is going to convert into the vapor, that time the temperature will remain constant. Up to there the temperature will remain constant. After it becomes the vapor, again the temperature is going to increase, right? Yes. Okay, this is what the experiment. So the ice has become water, right? Yes. Next is effect of change of temperature. How this temperature is going to affect. Okay, so when the temperature is provided with the help of the burner there, okay, heating is started. So when the heating is going to take place, the kinetic energy of the particles is going to increase. What is kinetic energy? The movement is going to increase of the particles. Okay, so as the heat is provided more, as the heat increases, the kinetic energy will also increases, and the particles is going to vibrate faster as well as move very freely. First the ice will be there. The particles are tightly packed, isn't it? The particles are tightly packed. When you heat, what happens? The particles will move freely. The kinetic energy, the movement will be more freely. Okay, so at the melting point, the force of attraction is going to weaken and the solid will become liquid. So I will explain you exactly what is going to take place. This is ice, right? This is ice, and here the particles are tightly packed, right? The particles are tightly packed, and I have already told you in the previous video that in the solid the force of attraction will be more, right? Here the force of attraction is more, the bond, okay, the force of attraction will be more. So now what happens is nothing but when you are providing heat with the help of the burner, now what happens, this heat energy is used to break the bond, to weaken the bond whichever is present, the force of attraction that is present in between the particles. Okay, so what happens is nothing but the particles, it is held by the force of attraction. That strong force of attraction is going to break and it is going to become weak. And what happens in the liquid, how the particles will be arranged far away, little bit far away from each other, right? It is going to arrange like that, and the ice is going to convert it into liquid. So that is why the temperature is not going to change, isn't it? I told you the temperature is not going to change. It is 0 degrees Celsius itself. Up to it is going to convert it into water. The temperature is going to remain constant. The melting point is going to remain constant. That is because the energy is used up to break the bond here, to break the force of attraction here. So that is the reason this heat energy is used to break the bond, break the force of attraction. Hence the temperature remains constant. Okay, so this is the melting point. At the melting point, when the solid is going to become liquid, how it is going to become liquid? The force of attraction is going to weaken with the help of what? With the help of the heat energy from the burner, from the flame, and the solid is going to convert into what? Liquid. Next, what happens? The temperature keeps on increasing, and at the boiling point, what happens? Again at the boiling point, after it reaches 100 degrees Celsius, the temperature is not going to change again. After it becomes liquid, after it becomes water, liquid, the temperature is going to increase. Okay, after it reaches to that of the 100 degrees Celsius, it remains constant. Okay, why it is remaining constant? Because now again the heat energy is used to break the force of attraction here, weaken the force of attraction here, and hence the liquid will turn to what? The gas, more far away from each other. It is going to turn into the gas, right? Yes, this is what it is going to take place. This is the effect of change of the temperature. So just remember, as soon as with the increase in the temperature, the kinetic energy is going to increase. Okay, so the kinetic energy is going to increase. Yes. So next, melting point. As I told you, melting point is nothing but the minimum temperature at which the solid is going to melt at the normal pressure. The ice is going to turn it into water. The minimum temperature, the temperature will remain the same, isn't it? 0 degrees Celsius. It is not going to change. It is going to remain constant. Why it is going to remain constant? Because the heat energy is used to break the force of attraction. It is used to break the force of attraction. So that is the reason the temperature is going to remain the same. Okay, in the Kelvin scale, the temperature is 273.15 Kelvin, right? Yes. Okay, the temperature remains constant during the melting, and the energy, why? Because the energy is used to overcome the force of attraction. To break the force of attraction, that energy is used. Which energy? Heat energy is used, right? Yes, that is about the melting point. Next, latent heat of fusion. What is latent heat of fusion? The same thing which I have explained you earlier. So now what happens is nothing but the heat is absorbed during the melting point without temperature change. As I told you, the heat energy from the flame that is used to melt the ice into that of the water, but the temperature is not going to change, right? The temperature is not going to change. This hidden heat, the temperature is not changed, but the heat is there. But that heat is used to what? To break the bond, to break the force of attraction. So that hidden heat itself is called as what? Latent heat of fusion. So why it is required? To convert 1 kg of solid to liquid at the constant temperature. Remember, during this latent heat of fusion, the temperature is not going to change. It is going to remain the same, right? So that is at 0 degrees Celsius. So the particles in the water have more energy than the particles in the ice, obviously, isn't it? So what happens in the ice? The particles will be like this. So when the particles will not be moving, right? So the energy is less over there. As soon as they will be provided with the heat energy, they take up the heat energy and convert that heat energy into what? Kinetic energy, and the particles will move. Hence the energy will be more in what? Water, right? This is water. So the energy will be more in the water than that of the ice, right? Yes. So that is latent heat of fusion. Next is about the boiling point. What is boiling point? So I told you. So after the ice becomes liquid, so the temperature is going to increase up to 100 degrees Celsius. Okay, the temperature, the thermometer will show the increase in the temperature because the liquid starts to boil, right? After it boils, it is going to show the temperature up to 100 degrees Celsius. As soon as it reaches the 100 degrees Celsius, again the heat from the flame is used to break the bond in the sense the force of attraction between the particles in the liquid, and then converts into gas. So that is why again the temperature is not going to change, because the heat from the flame is used to break the force of attraction. So that's why the temperature is not going to change. Okay, so the heat is supplied to the liquid, so the particles again moves faster. So the heat is supplied to the liquid starts to boil and the particles will move faster. So what happens at 373 Kelvin, which is nothing but 100 degrees Celsius, the liquid is going to boil at normal pressure. Boiling point is nothing but the temperature at which the liquid is going to turn into what? The vapor. So the boiling is a bulk phenomenon, right? So all of the particles has to be undergone the movement, right? So it has to, the entire liquid has to undergo the heating process and has to reach 100 degrees Celsius. So it is a bulk phenomenon. Yes. So latent heat of vaporization, the same thing which I have already told. So as soon as at the boiling point, which is 100 degrees Celsius, now the heat energy is absorbed and temperature is not going to change. Temperature remains constant, which is 100 degrees Celsius. In that case, how much degrees Celsius? Latent heat of fusion, 0 degrees Celsius. Here it is 100 degrees Celsius. After it reaches 100 degrees Celsius, the heat energy is going to be absorbed and used up. Why? Now tell me why. Yes, very good. In order to break the force of attraction between the particles completely and convert the liquid state to vapor state, right? So hence it is called as latent heat of vaporization. Now very much obvious that particles in the steam, that is 100 degrees Celsius, which will be having more energy than that of the water. That is obvious, right? So in the water, the kinetic energy will be less, because what happens is nothing but after that, so that heat energy has been used to again what to break the force of attraction between the particles. Hence obviously what in the steam, in the vapor, in the gaseous state, what happens, the particles will be having the more energy compared to that of the water. Yes. So next is about the Kelvin scale. This is important. Such type of questions they will ask to convert the Celsius scale to Kelvin scale, which is very easy. You have to use this formula. K is equal to degree Celsius plus 273. Okay, so for example, if the degree Celsius is 0 degree Celsius, K is equal to 0 plus 273. What is the answer? 273 Kelvin is the answer, which is very easy, right? What is the SI unit of temperature? Kelvin is the SI unit of temperature. I'm pretty sure you all know it already. Next is one more activity is given in your NCERT syllabus. What you have to do is nothing but you have to crush a camphor. You know camphor, isn't it? That is kept in between the saris and all. You might be known, right? Or the naphthalene balls as well. So naphthalene balls, camphor that is being kept in between the saris and all, in order to prevent the damage of the burks and all of that. So what you have to do is nothing but you have to crush the camphor, and you have to place that camphor in the china dish, and you have to cover it with the inverted funnel. Okay, and in the inverted funnel it will be like that, like this, right? You have to plug a cotton plug over here. Okay, cotton plug must be plugged over here, and you have to heat with the help of the burner. Now what exactly happens is nothing but I'll show you. So this is the picture. So what happens is nothing but this is the burner. So this is the china dish where you're going to keep the camphor, and you're going to keep the inverted funnel like this over here, and you're going to keep the cotton plug so that the vapor will not escape outside. For that reason you're going to place a cotton plug over here. Now as soon as you're going to provide the heat with the help of the burner, what happens? The camphor is directly going to convert into which state? Gaseous state. The vapor, it is going to form the vapor without converting into the liquid state. It will not convert into the liquid state. So camphor is obviously solid. From solid, what happens? It directly did convert into which state? Gas state. So this process is called as sublimation. What do we call it as? Sublimation. Okay, what do we call it as? Very easy, sublimation. Now what happens is nothing but this gas, since I have plugged cotton plug over here, this gas will deposit here and convert it into the solid. Deposition will be taking place here. The gas, without converting into liquid state, has directly converted into which state? A solid state, right? The gas which is developed from here, evolved from here, is deposited here as the solid. So here the gas is directly converted into solid. So this is called as deposition. This is called as deposition. From solid to gas directly, it is called as sublimation. From gas to solid directly, it is called as deposition. Right? Yes. So that's about it. So the heating, the camphor will change directly into that of the solid state. Okay, so, the solid will be directly converting into that of the gaseous state, so which is called as sublimation. Yes. Okay, so the solid is directly converted into gas without liquid, sublimation. Again the gas is going to directly convert it into solid without liquid. Again it is called as deposition. Important. Yes. Next is about the effect of pressure. So pressure, along with the temperature, even the pressure plays a very important role in changing the states. So by applying the pressure as well as reducing the temperature, the gases can be liquefied. You know LPG, right? Liquid petroleum gas. You know about CNG, compressed natural gas. So all of these gases are have been stored in the cylinder, in the state of the liquid, right? So the liquefaction is being carried out, right? So how? By increasing the pressure and decreasing the temperature. By applying the pressure and by reducing the temperature, all these gases can be converted into liquid, right? Yes. For example, solid carbon dioxide, which is also called as dry ice, that is going to directly sublimate into what? Gas. It is solid, can be directly sublimated into that of the gas. Okay, so by high pressure as well as the low temperature, the liquefaction of the gases can be done, which I have already told you, right? Yes. So pressure also plays a very important role in the conversion of the states of matter, right? Next is interconversion of state, the solid to liquid, liquid to gas. The changes will be taking place depending on the temperature as well as the pressure, right? This is in your NCERT syllabus, which this one chart itself will tell you the entire process that is taking place. See, solid to convert it into liquid, fusion, right? Fusion, latent heat of fusion. Now the liquid to gas, vaporization. Now gas to solid, we have seen in the the camphor experiment, deposition. The gas is directly converted into solid by deposition process. Now the liquid directly converted into solid by the process of solidification, and again the gas is converted into liquid by the process of condensation. You know, isn't it, water cycle? The same process, the cloud will be there, the cloud condensation and the rainfall will be taking place the same way. Gas will be converted into which state? Liquid state. Okay, so the condensation. Now the solid directly converts into gas, which you have already observed in the camphor experiment, which is called as sublimation. So this is the interconversion of the three states of matter. So read this chart, important. Yes. So that's about it. So today what we have learned, so the matter can change its state by the changing the temperature as well as by changing the pressure, right? Once we will revise each and everything so that all the concepts are crystal clear for you people. So as we have told, the matter exists in three states: solid, liquid and gas, right? So the change in the states of matter is going to change based on the temperature as well as pressure. So what exactly happens is nothing but so with increase in the temperature, what happens is nothing but the kinetic energy is going to be increased. Okay, the kinetic energy is going to be increased. So that is the effect of the change of the temperature. What do you mean by melting point is nothing but, so it is a temperature at which the solid is going to melt at the normal pressure. So the melting point is 0 degrees Celsius. So during the melting point, the temperature will not change, it will remain constant. So what happens when you are going to boil the ice? What happens? The ice will be converted into liquid. So the temperature is not going to change. So the ice is going to convert into liquid. That itself is called as melting point. The temperature remains constant, which is 0 degrees Celsius. Why it is remaining constant? Because the heat energy. So why it is remaining constant? Because one second, I'll show you why it is remaining constant. Because this heat energy is used in order to break the force of attraction or weaken the force of attraction that is present in between the ice. So because of this heat, the kinetic energy will increase and the particles will going to move faster, right? So that is the reason the temperature is not going to change, it is going to remain the same. So the latent heat of fusion is the same thing. The heat is being absorbed and the temperature is going to remain the same. That hidden heat itself is called as latent heat of fusion. That is used to change 1 kg of the solid into the liquid at the constant temperature. The temperature is going to remain the same, right? Yes. So at 0 degrees Celsius, the particles in the water has got more energy compared to that of the ice. Obvious reasons, isn't it? The temperature will be more over here. So as the temperature increases, the kinetic energy increases. Yes. Okay, boiling point is nothing but as soon as the liquid boils and reaches 100 degrees Celsius, what happens? It is going to convert it into the gaseous state or the vapor state. So that is nothing but called as boiling point. So when it is going to take place at 100 degrees Celsius, it is going to take place because after it reaches to, liquid reaches to that of the 100 degrees Celsius, what happens is nothing but the flame, the heat energy from the flame is used up by the liquid to break the force of attraction between the liquid particles and to convert it into the vapor state. So this boiling point is going to take place at 100 degrees Celsius. After the 100 degrees Celsius, what happens? The temperature is going to increase Okay, so until then the boiling point is going to remain the same, because the heat energy has been used to break the bond or the force of attraction between the particles of the liquid, right? Yes. So latent heat of vaporization is the same thing. So at the boiling point, which is 100 degrees Celsius, the heat energy is being absorbed without changing the temperature, without increasing that of the temperature. Why? In order to break the force of attraction between the particles and convert it into vapor. So the particles in the stream will be having obviously more energy compared to that of the water. So Kelvin scale, this is the formula in order to convert, which is very simple, degrees Celsius plus 273. And there is one activity where we are going to take the camphor and we are going to heat it. We are going to place the inverted funnel, the cotton plug. Once again, the cotton plug will be placed over here. So what exactly is going to happen? So the solid is directly converted into that of the gas. So that process is called as sublimation, and the vapor is going to deposit here. So this gas is directly converted into solid. So that process is called as deposition. So we learned about that. So pressure also plays a very important role. By applying the pressure as well as reducing temperature, we can liquefy the gases. So the interconversion takes place based on the temperature as well as the pressure. So this is again important. The solid to liquid by fusion, liquid is converted into gas by vaporization, gas to solid by the deposition process, and from liquid to solid by the solidification, from gas to liquid by the condensation, from gas to solid by the process of deposition. So that's about it, my dear students. Okay, so I have inserted a quote here. Please go through this quote, which says that science is simply the truth about the world we live in. This is true, isn't it? Yes, that's it for today, my dear students. Let's meet again in the next video. Please do not forget to like, share and subscribe. Until then, keep watching, keep learning, and very, very, very importantly, as I say every single time, please enjoy while learning. That's it. See you. Bye-bye.